doing inverse trig functions is I want you to think back to what you did in geometry. Think about this problem. If you were given a right triangle and you had to find theta, I mean, you guys called it x back then, but we're going to call it theta because we're cool. I thought that was you falling out of your chair at first. I was like, oh no, you're okay. If you had to find theta in a problem like this, what trig function would you have? You'd have to use sine. Everybody okay with that?
Yes.
We would say this, that the sine of theta is 3/7.
Yes.
What was the button you had to press on your calculator to do that?
Inverse.
Inverse. You'd have to say that theta was equal to the inverse sine of 3/7. What was it, 25/38, I think?
You haven't changed the
25.38. So your angle would be 25.38 degrees. Because we're talking about a triangle we're within degrees right here. So what you did there is you did the inverse. You were asking yourself, what angle has a sine of 3/7? Well, hit the inverse button. We do the same thing in this class, but we're dealing it with reference angles. We're going to deal with it in terms of what angle has a sine of √2/2. What we're going to do here, is we're going to figure out what angle has a sine of √2/2. That's what this is. Yes, ma'am?
So we just put it in radians?
No, because you don't get a calculator.
Dirty. Are we going to have on our test like a non-calculator?
Yes. Now, what I want you to do here is think of, hold on. Think about what we have here. We have √2/2, and we're not using calculators, which means you have one of the two triangles that you're probably working with. Which one do you think you're working with?
45.
The 45. And why do you think we're working with 45s? Because there's a √2 in there.
And it's like Q. Oh, wait.
So, which of those angles has a sine of √2/2?
90. Wait.
45. Okay. 45 degrees has a sine of √2/2.
Wait, so are we only going to be dealing with 90s and 45,
Oh, I get it, because isn't √2/2 the same thing as 1/2?
And remember, we're bouncing it back and forth between radians and degrees. So in this case here, 45 degrees is still pi/4. Okay? Now, the only other thing you have to concern yourself with is the sine value of √2/2 occurs in more than one spot. Remember when we dealt with that in terms of where, well, let me ask this. Where was sine positive? Which two quadrants?
The one.
The one, yeah, yes, those. 1 and 2. Here and here. So both of these angles at pi/4 and 3pi and 3pi. Both of those angles had the sine value of √2/2. What we're looking for is just going to be one of them. Now here's what happens. There's going to be 3 scenarios for sine, cosine, and tangent for what quadrants that you're going to be looking for your answers. The values of sine that we're going to be looking for when we're trying to find sine inverse problems, we're going to look at it between pi/2 to negative pi/2. We're going to look at all of our sine values to be between pi/2 and negative pi/2. That way we're encompassing all the positive sine and negative sine values. Okay? We don't have to worry about bouncing them and getting reference angles off first and in the second quadrant or anything like that. We're just going to find a positive, or it might be a negative angle, depending upon where it lies. Okay? Excuse me. Now, the other thing is that the sign values fluctuate between, let's see, our ordered pair here was at 0 and -1, and here our ordered pair was between 0 and +1. So your values of sign can only be between 1 and -1. So can you ever have a sign value greater than 1? No. Nope. Okay. Cosine. Cosine's a little bit different. When we're working with cosine, inverse problems, we're going to be looking at cosine values between the first and the second quadrant. When we're working with cosine values between the first and the second quadrant, remember what your ordered pairs are. Here you're at 1, 0. Here we're at 0, 1. And here we are at, what was it, -1 and 0. So this is between 0 and pi. So we're dealing with cosine. The first two quadrants encompass all the possible values of cosine that we're going to look at. Remember, they are mirrored into the third and fourth quadrants with other reference angles and stuff. But we're only going to look at them to find one solution we're doing today. It's just between those first two quadrants. Christian, you look like you want to ask me something.
No.
Good. Didn't want to answer it anyway.
I think it's good.
All right. Not bad?
Wait, don't move on.
Once you see the problems, it's one of those things you just can find your reference angle and go for it. It only gives you those two quadrants. All right. The last one is the weird one, and that's with tangent. So what happens with tangent is what occurs on the quadrantals vertically. Remember it was undefined? I showed you guys that the asymptotes occurred because you couldn't take, here it was at 0, -1, 0, +1, and here we're at 1, 0. If I'm taking a tangent value, it's y over x. What's that? I'm not going to bother because it's going to be first and fourth again.
Oh.
But what I want you to see here is what occurs on the vertical is that's the asymptote. We can take we can find the sine of 90 degrees. It's not a big deal. It's 1. We can find the cosine of 90 degrees. It's not a big deal. It's 0. Because you're not dividing by 0. When you're going to the tangents, remember, you can't divide by 0. That's why they throw an asymptote there. So your range of possible tangent values are going to be between -1 and +1, but not including 1 and -1. So it's less than or equal to, or greater than or equal to.
So it would be a open circle?
Yeah.
What?
Yeah.
I'm totally
Can you divide by 0? That's all we're doing. That's all it is. So your tangent values, again, are going to be between, your theta stuff is going to be between pi/2 and -pi/2. And just like you were saying, the open circle, I'm not including. Because when you have sine, you can include it. When you have cosine, you can include it because you're not dividing by 0.
So it's just like the sign now?
Yeah, just like the sine nav, but there's an asymptote because you can't divide by 0. That's all. So your tangent values will always be first and fourth quadrants.
Okay, so the sign map includes...
Yes.
Okay.
Because remember, sine is y over r. In the unit circle, your r value is always 1. Tangent is y over x. At 90 and 270, x is both 0. That's why you can't divide by that. That's why you can't find it. So, yes, ma'am.
Okay, good, okay. I understand why like sine of 90 is 1, but why is cosine of 90 0?
Well, think about what happens at cosine of 90. Cosine of 90 degrees, when you're plotting it, you're on the quadrantal, your ordered pair is 0 and 1. You agree?
Yeah.
What's your r value there? 1. Remember, to find r, it's x squared plus y squared, take the square root. So it's 0 squared plus 1 squared, square root is just 1. So your x is, y is, and r is 1. Cosine is x over r. At 90 degrees, what's your value of x? What's your value of R? What's 0 divided by 1? That's fine. WH1, not just the letter Y. Okay. Does that make more sense?
Yeah.
Because then we have sine, your x or your y value is 1, your r value is 1. Back to where this is going then.
Sorry.
No, it's a good question. It's quadrangles are weird to get accustomed to. What angle has a sine of 1/2? That's what you're asking. You're asking what angle has a sine of 1/2. So what I want you guys to get in the habit of thinking here is what triangle does this go into? It's a 30, 60, 90. Which of the two triangles has one and a two?
A 1 and a 2 are.
Yeah.
Oh, this is easy, because then what option?
You use your reference angle, your triangle, to figure out, all right, which one of these is sine value is 1/2? Well, it's 30 degrees.
30.
So I know it's going to be 30 degrees. Sine is between first and third quadrant, so I'm okay by being 30 degrees here.
What do you do?
What is that in radians then?
Oh,
Pi over 6. What I want you guys to get in the habit of here is using both. Use radians and degrees on these. Because when you do these on the test and quiz or whatever I wind up doing, whenever we wind up having one,
will it be this week?
I have no idea. The whole park schedule's messing everything up.
Not this week.
Not this week. I want to spend a couple of days on this. I probably need a good solid because I won't be here on Friday. I probably need a good, this Friday. I definitely need a whole nother day tomorrow to do more of this. And then on Friday, I probably have like a little culminated like worksheet combo thing for you guys on this. Yes, ma'am.
During the 2 days while we're taking the book, what will we be learning?
Something.
We're only in here, yeah.
Yeah, you guys will you'll have the class. What'll happen is if it's gone for 2 days, you'll still see me. We're still going to go teach one of those things, and I'm just going to repeat that lesson for the other class the other day. We're going to double lap stuff. So, yes, ma'am.
For the park, it says to be there at, well, it starts at 10, to be there at 10.
They'll make an announcement like they did today.
They're just gonna
So
call
it
us.
doesn't start at 10.
It'll be a couple minutes here.
We're gonna have like paper to write on during it, or do we have to do everything?
Everything's on the computer.
We can have like sketch.
No, everything's on the computer.
We had sketch paper last year.
Yeah, everything's on the computer.
That's so.
You need a calculator. You can bring your calculator. Yes.
Oh, no, not the computer.
I don't really remember what like Rob was saying, but he said something in class about like how during the park they're not allowed to teach any more curriculum.
Well, I mean, we're gonna
No.
be learning it anyway.
It's not that. It depends on what class you have. I mean, like with Mr. Rouse being in Spanish, a lot of his classes are just being. So yeah, that's what this looks like. It's not bad. It's just a matter of getting used to it. Let's try another one. Sine inverse of negative root 3 over 2.
This is gonna be 69.
Why do you say it's 30, 60, 90?
Because it has
Because it has root 3 in it, okay?
it's opposite over pi over 60.
So we know,
Yeah.
we know it's the 60.
Why is it negative?
Wait, so is that is
Oh, because
60?
the positive.
Uh-huh.
Write it down.
Is 60 our answer for degree? Like that's the angle?
Ooh,
For degrees, but not yet. I mean negative.
negative 50.
Yeah, but that's what I mean. Like negative 60 is the
So it's gonna be.
degree answer, right? That's the
Oh, because
angle.
it's sine, so it has to be in the fourth or
Right.
first quadrant. Since it's
Now,
negative, it has to be down there.
Remember the parameters to this. It was between pi over 2 and negative pi over 2.
Yes.
It didn't go to 3 pi over 4 or 3 pi over 2 or anything like that.
Right.
What's up?
So when it comes to the actual like radian that
Mhm.
we're gonna write for the 60 degrees, are we gonna do that like off of a reference angle, like?
No, because you're
go all the
between.
way on, so
No, because you're between pi over 2 and negative pi over 2. So your angle here is negative pi over 3. Go to the next problem. Okay?
Oh, because you
Over 3 is with 60, over 6 is with 30.
Yep.
Over 4 is with 45.
Yes, please. I think it asks you and book and stuff like that, give you both radians degrees. Okay? All right? Cosine inverse of negative root 2 over 2.
We did this. It's negative 45.
Ah, careful. Cosine is first and second quadrants.
Oh, you're right.
So it's, remember, it's a 45-degree angle.
So it's half 45.
No, negative.
45. I said negative.
But remember, your cosine values are between, this is where you have to be careful. It's between 0 and pi. So come on over here.
I'm going to get this wrong.
It's at 135 and 3 pi over 4. It has the reference angle of 45 degrees. Bounced up, we're looking for cosine values between the first and second quadrant, which gets us, oops.
What?
135 or 3 pi over 4.
Where did the line come?
You drew it.
Why?
Why is it 135?
Cosine values. Again, cosine values that we're looking for, 0 and pi. That's where our cosine answers are going to occur. This is why I said you need to remember where these things occur. This is the important stuff.
Just wanted to let you know that the 10 a.m. session of Park has finished. Any student that has tested during the 10 a.m. session or will be testing during the 12:30 p.m. session who is testing over their lunch period will be eating during 8th period. Please refer to Ms. Atkins' email to double check on this, teachers.
Are you going to look at the email?
To be honest with you guys, cosines are going to be the ones that you forget about going between first and second quadrant. That's usually where people make their mistakes.
Tangent or sine are like the same.
So, try these.
These. This is Spanish. Is estate that?
Try those three real quick. Take a second.
All different problems saying it.
Go.
It's what's on Sparkboard?
Uh-huh.
Oh, I didn't say 5B. I was like, what?
For cosine to be 0, we're looking from here to here. Here's 1, 0, 0, 1, negative 1, 0. Which one of them has a cosine of 0?
90.
90 degrees. What's that in radians?
Pi over 2.
Go to the next problem.
You're on fire.
Tangent. Which angle has a tangent of root 3 over 3?
30.
30. So if we are at a 30, 60, 90, oops. It's root 3 over 3 at 30. Tangent, I'm positive, I'm looking between pi over 2 to negative pi over 2. 30-degree angle is?
Pi over 6.
Very good. Tangent negative 1.
It's a 45.
Or negative 35.
This one has to be, in order for it to be tangent to be 1, it has to have the same side lengths, which is the 45s. Now, remember again, tangent being between pi over 2, negative pi over 2. There's the open surface for you. Being negative 1 means I'm down over here. at negative 45 or negative pi over 4. Remember, like I was saying, your parameters for tangent will be between pi over 2 and negative pi over 2. You do not have to continually go around to find the actual angle within the unit circle when we're setting them up like this. There will be a time for that eventually, but not quite yet. All right? What this is going to allow us to be able to do, probably tomorrow now, which is going to be kind of cool, is we'll be able to do this. Think about order of operations. Order of operations tell you to go the inside out, right? So, real easy. What angle has a cosine of root 3 over 2?
30. Sorry.
Cosine inverse is root 3 over 2. So that means it's a 30-degree angle, which is pi over 6, correct? So what's the sine of pi over 6? What's the sine of pi over 6?
Oh, then 6 over 30.
It's 1/2.
That's so crazy.
So the sine of the inverse cosine of root 3 over 2 is 1/2. That's a composite trig function. They do a lot of that pre-calc. So I'm going to introduce it to you guys tomorrow. It's just it's a puzzle. It's undoing it. See what you can come up with. Okay? Let's do these. 13, 4, 795.
Why are you so mad?
18.
Let's do those for now. Okay?
Thanks. Bye, see you tomorrow.
We'll continue to go into the, there's a couple other parts of this unit that we will use the calculator stuff off of. You'll have to make sure you have it tomorrow. Right.
Oh, that's literally my life. Mine's worse. Today for practice, I'm wearing a hoodie from 2001.
On average, 2 chargers.
Last year, I was
chargers that I bought for my
I've like the collection. Like I've done it over years. I've been working. I have like counted. I have 3 units.
Next week you're like, what? I'm ready to go. Let's go.
That's like 3
Unless they want to like there's only 15 trying out and there's probably going to be about like 4 or 5 in this guy. There's like Skylar, Jenna, Maya, Tori, and Corbin. And
What are you talking about? Allie, what are you talking about?
softball. I remember when Claire used to play softball.
I was good.
Yeah, you were. Yeah.